Morning guys, I'm going to tell you today about something that happened a couple of days ago. This is a landing on an asteroid. We sent a space probe called OSIRIS-REx out to land on asteroid Bennu. Now Bennu is an asteroid about half the size of the planet Mercury. So it's a little bit wider than, like, let's say this little blueberry. We'll use this blueberry today. The blueberry is asteroid Bennu. And asteroid Bennu is what's called a near-Earth asteroid. And here's the sun, and it's traveling, and it's orbiting the sun. Orbiting the sun just like all the planets do, but it crosses over the path of the planets, and it's closer. We call it a near-Earth asteroid because it's 200 million miles away. Now, most of the asteroids in the asteroid belt are more like 250 million miles away. So it's close enough that at some point it could crash into us, but chances are small. Chances are always small. Because it's 250 million miles away, when we send a space probe to it, we have to plan out the exact details of what we want it to do. These instructions were laid out very specifically, and this is one of the reasons why I've been giving you guys assignments for giving me exact instructions on things, because it's so important to communicate effectively what steps need to happen and to anticipate what could go wrong. It takes 19 minutes for a message from Earth to make it to asteroid Bennu, so we want to make sure we've planned that out well in advance. So here's a little model I made of the space probe OSIRIS-REx. It's got a couple of wings that extend out like this, and hole on one end on the front of it, and a cap on the top. So this is about what it looks like. These panels that it extends, these are solar panels. These are one way for it to get energy while it's out there, and it can get power by extending. And then it can collapse these when it needs to do other things. OSIRIS-REx is about 8 feet wide and 20 feet long and then 10 feet tall. So it is about the size of 2 cars parked next to each other in a garage. The goal of the mission is to collect dust and dirt and debris from the asteroid Bennu. We want to know, what is it made out of? Because the things that are floating out there in space that do not have atmospheres, that don't have weathering, that don't have erosion, these are things that will tell us about the early solar system. They haven't been changed very much since they first formed, and if we can bring back a piece of that to Earth, then we can study it. And one of the reasons we want to bring it back in a space probe is that it's protected. When we get meteorites that fall through the atmosphere, they come through the atmosphere, and the friction of the atmosphere actually burns them and melts them and crystallizes them in a way that we still have details about them when we get them on Earth, but we don't know exactly what they were like, and we don't know what something is like that's already out there that hasn't been touched yet. So our goal for this mission was to go out, land on the asteroid, and collect about 60 grams worth of material. 60 grams is not a lot. It is about the mass of this tomato, but that's more than has ever been collected. We've had other space probes that have landed on asteroids and they've collected dust, but this is aiming for a much bigger target and much bigger payload, as they say. So Bennu orbits the sun about once every 14 months, and it likely formed as it broke off from a piece of a larger asteroid in the asteroid belt. The way that it is formed, we really think that it was something where it was a smashed scattering of debris that eventually started clumping together as the gravity from the masses of the different particles started getting closer and closer together, forming a larger and larger asteroid. This is how we think that it formed. It's a lot like how we think planets formed. We think that the gravity of each individual particle started acting on other individual particles and would bring them together. Now, because of this, we actually have evidence based on measurements we've taken that Bennu is about 40% hollow in between all of its particles. Like, all of these pieces came together, but because there wasn't mass of a larger planet pulling it together, it ended up being kind of squishy. In fact, if Bennu was to be brought back to Earth and set down on the ground, the gravity of the Earth would actually squish it, and it would no longer be a round asteroid. So the shape of Bennu is kind of round, but it's got a bit of a ridge in the middle, and we call that top shape, because of its extra wide ridge around its equator. Bennu doesn't have enough gravity to form an atmosphere. It just doesn't have enough mass. That means that the temperatures range from 240 degrees Fahrenheit to negative 100 degrees Fahrenheit, because once it gets the heat from the sun, it heats up, but in the shadows, it doesn't have anything to hold on to that heat, so it drops down to a low temperature. A couple of last notes about Bennu is where the name came from. The name comes from an Egyptian god. The god was Osiris, which is where we get the name for the OSIRIS-REx, and Bennu is named for the heron, which is the living embodiment of that god in Egyptian mythology. That's it for today, guys. Take a look at some of these links to learn a little bit more about asteroids and Bennu and OSIRIS-REx. Have a great day.